With increasing digitalization, industrial companies have more and more data at their fingertips. Sharing this data with cooperation partners in digital value networks has many, many benefits. But it also has risks. A prime factor holding companies back from sharing their data is the risk of losing data, of revealing know-how, where the revelation of this know-how sets them as a competitive disadvantage. So how to think about this? Well, here's an easy, stylized decision process. It starts with the objectives and the use case. There's no one-size-fits-all answer to which data to reveal and which know-how to protect or the like, but it's very scenario and use case specific. So first you need to think about the data which would be valuable for sharing. Because this data, it has know-how in it. It reveals know-how. And that is a good part because you need that for the joint analytics, joint in the digital value network, and gaining operational and then economic benefits from the data. But on the other hand, you might not want to lose this know-how. You might not want to disclose it to others. So you need to also think about the protection requirement and plan protective measures for not revealing the valuable know-how, but releasing data which still allows to capture the benefits. And in this video, I focus specifically on this protection element in the decision. How do you do that in a little more detail? Well, there are primarily 4 questions to answer. You start with a phase of understanding. So the basic question there is, what do the work system and its element look like? First, you need to understand the different elements. Who are the customers? What are the products and services the work system delivers? What are the key processes and activities? Which information is used in these key processes and activities? By which actors and with which technologies? So you need to model the work system and really understand the information needed there and used there. And then you'll likely do some deep dives on especially the technology and the infrastructure to understand where and which systems for which applications and the like is the data used. You'll likely do a deep dive on the processes and activities to understand at what point in time, by whom and so on should the data be used. You likely do a deep dive on the data to understand in detail which different variables are available, which of these might be potentially relevant for sharing, which of these are truly relevant for sharing and the like. And you'll do a deep dive on the participants because it matters to whom you disclose data, to whom you disclose know-how. So you want to know which participants are in the work system and in which of the different process steps do they interact with which part of the data. So all these deep dives are interconnected, but they take different perspectives, they take different foci on analyzing the work system and seeing which data you share. This is the understanding part. Then you go into the next step, identify and prioritize the risks. So the basic question to ask there is, what can go wrong? What happens if you share the data? What are the big risks? What might others find out about you, your products, your production capacities or the like if you share this data? Then in the third step, you go to protective measures. The basic question to ask is, what can and should be done about it? Or are we already doing it? Do we need to do more? And then last, you go into the verify stage. The key question to ask there is, have all risks been identified and adequately addressed in the planning? Or do you need to circle back because you identified new risks, or you see that your planning, your protective measures are not sufficient yet for addressing the risks? And what you see on the right-hand side is the procedure. So first you model the work system, then you find risks, then you plan how to address the risks, and then you validate the risk planning. This process is roughly based on Yadav and Dong's work from 2014, and then applied to this specific scenario of data sharing in digital value networks and specifically modeling it as work systems. What you see here is a stylized system architecture of a collaboration structure in a digital value network. It starts at the lower left-hand side with the product or the machine on a manufacturing side. And that machine has hardware and software. Then you gather data from sensors in that machine, and you might want to share this data with others. But first, via a network communication connectivity, you probably send it to an enterprise cloud. There can be different setups, different architectures. This is one exemplary and stylized architecture. And this enterprise cloud likely has something like a database, an analytics engine, and some applications, potentially smart applications running on that, and likely it's integrated with other business systems. And then you might want to share it with others. This is still the same company which owns the enterprise cloud and the product, the machine in the first place. And then you can share it. For example, you could go to an industrial data cloud, so a party specifically providing that cloud for data sharing. And there again, you would have something like a database, an analytics engine, and applications. And from there, it might go on, for example, to another industrial company, for example, your customer with whom you want to share data. As said before, there can be other architectures. You don't necessarily need this industrial data cloud. It could be bilateral, going from enterprise cloud to enterprise cloud as alike. And what you see with the red dots are that these are connectors, so these are specified endpoints where the data is shared and transferred. Now, what this stylized architecture can help you with is seeing where can you apply which of different protective measures. And there are many. We are at the moment working on identifying many protective measures. We have a long list. We built a taxonomy of that. Here I show you some of them exemplarily. One very simple protective measure is do not collect data. If you think that the data includes know-how which is so valuable that you really want to make sure that you don't lose it, well, then don't collect the data in the first place. Where in the stylized architecture does it apply? Well, you see it on the lower left, on the hardware or software part. Either don't include the sensors which would take the data at all, or once you got it in the software, delete it again right away. So that's do not collect, which is probably the strongest protective measure. Nothing can go wrong from the risk side with that, but also it's the most detrimental for the benefits, because if you don't have the data, you yourself can't work with it, you can't share it with others can't work with it. So it's the most radical of protective measures. Another less radical one would be number 2, deletion after time. So you might first have it in your database, you might also communicate it to the industrial data cloud, you might want to share it with others. But over time, when it's not relevant anymore for the desired use case, for the operational benefits you want to get, you might delete that data and you might have others delete it, which would then obviously require, on the one hand, contracts with them, on the other hand, trust in them that they truly delete it, so that nobody can use it anymore, so that the risk is gone after you don't have the benefits from it anymore. Still another measure would be demaskable data masking, which you might use, for example, here on the connectivity layer, so that we can talk about different methods of cryptography. Another measure would be the permanent data masking. Compared to the demaskable data masking, which can be undone, a permanent data masking can't be undone anymore. So with that, you limit usage potential of the data, but also you reduce the risks. And that's always, for all of these protective measures, the trade-off you need to take. And for knowing which trade-off is reasonable there, well, that depends on how big the risks are, what know-how might be lost in that data, and how strongly do you limit the benefits when you apply that measure. And that can only be determined once you also consider the part of the benefits. Once you've done the data capturing, you do the analytics, you see which benefits it leads to, and then you can weigh risk against benefits. And that's specifically done in this integrated techno-economic decision. And what might that look like? Again, very stylistically. What you see on this chart is on the horizontal axis, the benefit for the data recipient. Think, for example, that a supplier sends data to the customer, then the data recipient would be the customer. And on the vertical axis, the risk for the data provider. Here's the supplier. It could be the other way around if data travels back along the value chain. But typically we see that the data recipient can do the analytics, can have the better models, can thereby improve its operations or its products and thereby get the benefits, while the one who discloses the data has the risk of revealing valuable know-how. And what you see in this chart are the 3 blue labels. A full disclosure of data on the upper right-hand side would likely mean maximum benefit for the data recipient, but also maximum risk for the data provider. On the lower left-hand side, no data exchange at all would limit the risk, but would also limit the benefits. And utopia would be on the lower right, if you can get to all the benefits without the risks, but likely that's not achievable in a realistic scenario. So what you need to do is to consider different sets of data the benefits you might get from these sets of data, but also the protection requirements. Then calculate with the different protective measures which we had before, how much do they reduce the benefit, how much do they reduce risk, and thereby you can plot different alternatives in such a chart, in such a simple diagram. And then what you see with the blue ones, these are the sensible measures. This is basically the efficient frontier. And the gray one are the dominated measures. So, for example, here, if you have a setting, a data set with attached protective measures, which we labeled here as number 9, well, that's worse than number 31, because number 31 is better for both partners. It's better for the data recipient in terms of benefit. It's better for the data provider in terms of low risks. So you shouldn't go for the gray ones, you should go for the blue ones. And with this, with thinking about the data, the knowledge encapsulated in the data, the benefits you can get from it, the risks you have, the protective measures, and then this integrated tech-economic decision, you narrow it down to a small set of potentially viable sets of data and protective measures for data sharing. And what you need next to decide among these different sensible measures is, well, that you basically have to negotiate in the value network with your partner or with your partners on which of these settings to take. If you want to move here to the upper right, then risks go up and benefits go up. This will likely require a higher payment from the data recipient to the data provider. If you move to the lower left, then risks and benefit go down, and this needs to be a negotiation between the different parties. In that you also determine the pricing of the data, and then you move on to implementing it, to capturing the data, to protecting it, to sharing it and the like, and monitoring and controlling the overall process.